All right, the next kind of antiderivatives we're going to look at are what if you can't just do it term by term. And like I said, there's no kind of opposite of product and quotient rule, but I like to think of this one as almost being the opposite of chain rule. And some are more obvious than others because, right, sometimes when you have parentheses, it's really easy to see something as an inside function. And so if you can recognize that inside-outside that you get in chain rule when you're trying to do an indefinite integral, that's usually a pretty good clue that it is a candidate for using U substitution. I will say the trig ones kind of hide a little more, because if we wanted to rewrite this, right, remember what this part where it says cosine to the 6th? That's the same as saying 14 times cosine of x all to the 6th power, right? It's cosine of x times itself 6 times. The fact that we put it right after the cosine is just sort of a shorthand to save a little bit of space. So when you rewrite it like that, sometimes it makes it a little easier for people to see that possibly this cosine of x could be treated like an inside function that's plugged into something to the 6th. And a lot of times when you start these, you don't know necessarily. Eventually you get better at them and you can see it easier, but you don't know if your substitution is going to work out. But you just set something as your u and you go with it and see if it gets you anywhere. Okay, so here I'm going to say what looks like the inside of another function is u equals cosine of x. I'm just giving it another name so that hopefully when I get the whole thing rewritten as u, I can make it a more simple function that I can take the antiderivative of. And so then step 1 is choose your u. We can even label them if we want to. Step 2 is take the derivative of your choice for u. So that's du dx, and derivative of cosine is negative sine. And then step 3 is get dx by itself, because we're going to try to replace everything we can in this original function, right? Where we used to have cosine, we're going to put u. And where we used to have dx, we'll put something that's equal to dx. And so you'll notice it kind of follows the same steps a lot, but multiply both sides by dx to get it out of the denominator. And then divide both sides by negative sine to get dx by itself. So you get du over negative sine of x equals dx. All right, so now we can replace this with this, right? Something that it's equal to. This is where the substitution comes in. And we can replace cosine with u, right? We set this up, we said u equals cosine. So over here, instead of cosine, I'll write u. And sometimes if you like a good color scheme, I'll even like leave the original stuff in the original color and put kind of my new information in a different color just so I can keep it straight. All right, then fingers crossed, hopefully some stuff here cancels out. And so notice how we have a sign on the top, sine of x and negative sine of x, and a sign on the bottom. So if we clean this up a little bit here, it will look like 14 u to the 6th. Don't forget there's still a negative, right? So we could either put the negative out here, or to be honest, you could even put the 14 out there and call it negative 14. Isn't going to affect our antiderivative. Dealer's choice. Some people like writing their constants on the outside and some people don't. All right, so negative 14 times u to the 6 du. All right, so notice we started out with this kind of big mess of a thing that we couldn't take an antiderivative of. And by substitution, we turned it into a really simple antiderivative, just something to the 6th. And so now we can go, well, what's the antiderivative of something to the 6th? Is something to the 7 over 7 plus c. And then don't forget this was multiplied by negative 14 before we started. And so then we'll see if anything cancels out. Negative 14 over 7 gives us 2 over 1. Right, they're both divisible by 7. And then we don't want to give them an answer in u when our original question, so we'll put our choice for u back in here. And so u was cosine, so our answer is negative 2 cosine of x to the 7th, which we can write in this notation if we want to. And if you also want to double check at the end, You could take this -2 cosine to the 7th of x. Notice how that would be a chain rule, derivative of the inside times derivative of the outside. Maybe because we're new to this, let's just do it just for fun. You could check and see if the derivative of that actually ends up being what you started with. I'll erase to make myself some space here. All right, so if we were going to take the derivative of our answer, and notice, right, cosine to the 7th, that means cosine is the inside. So we have something to the 7th power, which the derivative of something to the 7th is 7 something to the 6th, right? It's like chain rule. And then times the derivative of the inside. Well, the inside is cosine, so derivative of cosine is negative sine. And then derivative of a constant like c is 0, right? So that's going to go away. And then if we clean this up a little bit, the negatives cancel. 2 times 7 is 14. So 14 cosine to the 6th times sine. Does that look familiar, right? Because the goal of antiderivatives is we should end up back where we started. We're doing what did it look like before we took the derivative. And so if you follow the steps of substitution, it should always work, but also just for fun, because we're better at derivatives than antiderivatives at this point, you can also take a derivative to check and see if your answer works.